Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 10.1, exploring graphs of quadratics. So a quadratic function is a nonlinear function. So this means it doesn't make a line. Okay? That can be written in standard form of y equals ax squared plus bx plus c. And a cannot be 0. And that makes sense because if a was 0, this term would go away and we'd be left with the equation of a line. Okay? So every quadratic function has a U-shaped graph called a parabola. So it's going to look like this. And it might be upside down, so like this. Okay. Today we'll focus on the graphs of quadratic functions when b is 0. So we're only going to try to figure out what the a and c control for the graph, and then next time we'll figure out what the b does. Okay. So the most basic quadratic function is y equals x squared. This is the parent graph. Notice the a value is 1, the b value is 0, and the c value is 0. So it's like this, 1x squared plus 0x plus 0. So the 0x and 0 go away, and the 1 we don't usually write. Okay? All right, so complete the table below and graph your solutions. The graph should be a smooth curve, and it should be a U-shaped curve, and it should connect all the points. So negative 3 goes in for x, so negative 3 times negative 3 will make 9. Negative 2 goes in for x, so negative 2 times negative 2 makes 4. Negative 1 times negative 1 will make 1. 0 times 0 is 1. 1 times 1 is 1. 2 times 2 is 4. And 3 times 3 is 9. And you can notice some symmetry to our table. 0 is our center, and then this way and this way match. Okay, so we'll go ahead and plot all these points. So 0, 0, and then 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, and negative 3, 9. And we're going to draw a nice curve here. Okay. All right, so this one's called the parent graph. We're going to figure out how we can transform the parent graph by changing the values of a and c today. Okay, so this graph is y equals x squared. There's some special parts to this. The bottom or top of the parabola is called the vertex. And every parabola has an axis of symmetry. So a place where we could fold the graph in half and the two sides of the parabola would be lay right on top of each other. So this is the axis of symmetry. And for our axis of symmetry today, it's the line x equals to 0. Now I drew this in dotted because this is not actually part of the parabola. It just shows us how the parabola works, the middle of the parabola. Okay. So the vertex of the parabola is the lowest or highest point on the curve. A line that passes through the vertex and divides the graph of the parabola in half is called the axis of symmetry. We drew that in already. And the axis of symmetry for our graph was x equals 0. And then it said label and put all these on there. So if you did not do that as I did it above, go back and watch that part of the video again. All right, let's flip it over and see the second page. On page 2, we have the directions go to this website. So you can type in this web address. Okay. And we're going to make a sketch of y equals x squared. So this is an online graphing calculator. So of course, if you have your own graphing calculator, you can use that instead. Okay. So what we want to do is explore how the sign of a in the quadratic function y equals ax squared affects the graph. So we're going to graph these four with y equals x squared at the same time and see what they look like. And notice in number 1, our a value is negative 1. In number 2, our a value is 2. In number 3, our a value is negative 2. And in number 4, our a value is negative 1/2. So this is a sign that's negative, and this one's a positive, just like our parent graph, and this one's a negative. And we want to see how it affects our graph. So let's give these 4 a try and see what they look like. All right, so the first thing we do is in y1, we're going to type x squared. Okay, that's our parent graph. That graph's going to end up being red. Okay, and then in y2, we're going to type negative x squared. And we want to see how it graphs. The green one will be our new one. So if we graph this, you can see our red one, this is y equals x squared. Same parabola we had when we sketched it ourselves. That's our parent graph. If I change it to negative x squared, we get our green graph, which just flips it all upside down. Okay? All right, so let's try our second one. So it seems like so far a negative will turn it upside down. So our second one was 2x squared. So this is a positive a value. Let's see what that does. So this one still opens upward. Okay, so positive numbers look like they open upward and maybe negative numbers downward. So let's try negative 2 just to make sure. That was number 3. So negative 2x squared. There's our original one. And our new one opens downward. Okay, so once again, a negative a value seems to make our parabola flip upside down and open downward. Okay, all right, let's try one more negative just to make sure. So negative 1/2, that was number 4 there, x squared. So this one, if we were right about it, should also open downward for our green graph. And it does. Okay, we'll figure out what the 1/2 and 2 do later, but right now the sign itself just seems to make our graphs open upward or downward. All right, let's take a look back here and put in this. So how does the sign of a in the quadratic function y equals ax squared affect the graph? Okay, well, if a is greater than 0, that means positive, then the parabola opens upward. Okay, it makes a smiley face. All right. Number 2, if a is less than 0, this is a negative value of a, then the parabola opens downward. So this makes a frowny face. Okay, if a is positive, so a is a big number, opens up. A is negative, opens down.
So in this next section, what we want to do is find out what the absolute value of a does. So if a was 2 or negative 2 or negative 3, we don't want to know whether it flips up and down, but how the graph changes besides the flip up and down. So let's take.
So in number 5, the absolute value of a is 1/3. We want to see what does 1/3 do to our graph. In number 6, the absolute value of a's value is 1/2. Okay, so we want to see what does 1/2 do to the graph. And in number 7, the absolute value of a is the absolute value of 2. So we want to see what 2 does to the graph. And in number 8, we want to see what 3 value of 3 does to the graph. So absolute value of 3 is 3. Okay, so we're going to explore those and then come back and write. Okay, so we'll take a look at our first one. We have a parent graph of y equals x squared, and I'm going to type in 1/3 x squared. So this was number 5. And we want to see how does it change our graph. So we already know the sign of a makes it open upwards or downwards. So we're going to ignore that opening upwards and downwards, just do some positive ones and see how it changes. So our first one, 1/3 made our parabola become wider. Okay, so it's like it got squished. Okay, let's try 1/2 and see if that's also squished or if it got skinnier. Let's take a look. So 1/2, this was number 6, also made our new parabola be squished, okay, or wider. In number 7, we want to try a whole number this time and see what happens. So this time we're looking at 2. If I graph this one, our parabola got skinnier, so it's like it got stretched, okay? So the original one was the red one, the new one's the green one, and notice it got skinnier. It fits inside of the red one. And then we'll try 3. So let's give this guy a go. So this one's also skinny. So normally the parent graph has an a value of 1, that's the red one. If we pick a number bigger than 1, it seems like the graphs get skinnier. And if we pick a number smaller than 1, like maybe 1/4, it seems like the graphs get wider. And that is the case. So let's go and write down our information for that. So how does the magnitude of a in the quadratic function y equals ax squared affect the graph? Okay, so if the absolute value of a is equal to 1, we get our parent graph. But if it's greater than 1, what happened? So this is like these guys, 2 and 3. Okay, when this happened, our graph got skinnier. So the parabola got thinner. Okay, and the math words for this is it had a vertical stretch. Okay, so vertical stretch is if I hold the vertex in the same spot, I grab the arrows of the parabola and pull upwards, it's going to get stretched, which will make it look skinnier. Okay. Now, what happened when our absolute value of A was less than 1? So remember, 1 is our parent graph. So like number 5 and 6, 1/3, 1/2, 1/4, 1/5. Well, the parabola, got wider. Okay, this is math words. It has a vertical compression. Okay, so a vertical compression. This is keeping the vertex in the same spot, smush the arrows down, okay, and makes the graph get a little bit wider. All right, let's flip it over and see what we're talking about here. So graph each function and compare the graph with the graph y equals x squared. So in number 9, y equals x squared is already done. So we know from this negative here that this should make it open downward, our new graph. Okay? Now we haven't moved the vertex around at all, so we know our vertex is going to stay right here. And it's going to open downward, and then the 1/2 is going to make my graph get wider. The absolute value of negative 1/2 is 1/2. Okay, so let's plot some points using a table and see if we can figure out how wide, how does the wideness factor work. So for instance, 0, so 0 squared, 0 and times negative 1/2 is still 0. So that's why our vertex didn't move. But if I try 1, 1 squared is 1 and times by negative 1/2 is negative 1/2. Now normally we go over 1 and up 1, but this time we're going to go over 1 and we're only going to go down 1/2, okay, which is 1/2 of the usual amount. Okay, if I plug in a 2, we get 2 squared, which is 4, and 4 times negative 1/2 makes negative 2. So normally we go over 2 and up 4. Now we're going to go over 2 and down 2, half of the usual amount. Normally up 4, now it's instead of that, it's down 2. Okay, half as much. So 3 would normally be 9, but 9 times negative 1/2 will make negative 4.5. So we only went down half as much again. So that's 2, 3, 4.5 right here. Okay, 4 would be 16 cut in half would give us negative 8. So at 4 we get negative 8. So this graph is wider because at each place where it normally would go up, it goes up only half as much. Or in our case, because it's opening downward, it goes down only half as much. Okay, so we don't need a calculator to graph this or the graphing calculator at all. Okay, and we don't really even need to make a table. We can just say, oh, okay, so normally it would open upwards, but a negative makes it open down. And normally we go over 1 and up 1, but now we're going to go over 1 and up half as much. Okay, so let's do that trick over here for number 10. All right, so ours is definitely going to open upward because we have a positive A value. Okay, A is greater than 0. And the absolute value of A is equal to 2, which is also bigger than 1. So it's going to be skinnier graph. Okay, all right, so 0, 0 is going to be our vertex still. Normally we go over 1 and up 1, but now we're going to go up twice as much to make it skinnier. So over 1 and up 2. Normally we go over 2 and up 4, but now we're going to go up twice as much, so over 2 and up 8. And that's why the graph gets skinnier. That's all that will fit is 2 points this time. Okay, so the 2 makes it get skinnier because we do a vertical stretch, and we stretch it up twice as much. The 1/2 makes it get fatter because we do a vertical compression, so we push it down so it's only half as tall. For our last part here, now that we figured out what A does to the graph, we want to examine what the C does. So this says explore how the C in the quadratic function y equals x squared plus c affects the graph. So the c is the part that's added onto the end, the constant term. So in number 11, the c is -5. In number 12, the c is -2. In number 13, the c is +2. And in 14, the c is +5. So we want to see, as I change c, how does the graph change? So let's take a look with our graphing calculator again and see what's changing. All right, so our first one, we have y equals x squared. And we want to check, how does x squared minus 5 change our graph? So we do a c value of -5. So if we graph this, okay, this shifts our graph down 5 spots. So the graph is the same size. It looks a little wider, but that's just because parabolas get wider as they go up, as they work up. So in this case, if I shifted this up, the green and the red would be on the same part. Okay. All right. So it looks like just a shift down 5. So if that's the case, then our second one, number 12, when I change this to 2, should shift the graph down 2 spots. So we'll graph that. Same thing happened. Okay, it's the same graph, it's just been shifted down 2 spots. So notice if I go over 1, up 1 still fits, and over 2, up 4 still fits in the same spot. Okay. All right, so number 13 was +2. So if our idea works, then this should be a shift, the green graph should shift up to the vertex being on 2. So let's give it a go. And it does do that. Okay. Same graph, just been moved around by moving it up and down. Okay. And then our last one, just to double check, number 14, we have +5 here. So if I graph that, it shifts the y-intercept up 5. So our vertex gets shifted up to the 5 spots. All right, so it seems like the c does up and down shifting. Okay, let's give it a go and see here. How does the c in the quadratic function y equals x squared plus c affect the graph? So number 1, if the c is greater than 0, the parabola y-intercept shifts up. Now you might say, oh, it's the vertex that shifts up. Shifts up c spots. Okay. And you're right in this case, but when we start putting the b in there, it moves the graph left and right, but that y-intercept still stays in the same spot. Whatever the value of c is, will be our y-intercept. And it's just like in a linear graph, when you cover up the x and term, the y-intercept is the part on the end in the mx plus b. Okay, so same thing. All right, so number 2, if the c is less than 0, the parabola's y-intercept, which in our case, this today was our vertex, but it will normally just be the y-intercept, not necessarily the vertex, shifts down c spots. All right, let's flip it over and put all of this together into one. All right, so in number 15, graph each function, compare the graph with the graph of y equals x squared. So what does this c value of -4 going to do? Well, it's going to shift our y-intercept down 4 spots. So I'm going to go ahead and move it down. 1, 2, 3, 4 spots. Okay, we haven't learned how to move it left and right yet. We'll get that next time. And it's controlled by the b and the a together. Okay, so a little bit harder to find. All right, so normally our graph, well, it's still going to open upwards because a value is positive, so it's going to be a smiley face. Okay, and normally it would go over 1 and up 1, but since a is 1/2, it's only going to go up half as much to make it be wider, or that vertical compression. So instead of over 1 and up 1, we go over 1 and up 1/2. Instead of over 2 and up 4, the normal graph, 2 over and 4 up, instead we're going to go 2 over and 2 up, half as much. Okay, and same thing over here. And normally it would be 3 over and 9 up, but we're only going to go half as much up, so 3 over and 2, 4 and 1/2. 4 and 1/2 is half of 9. Then it would be 4 over and 16, so we'll go 4 over and 8 up. So that's 5, 6, 7, 8. Okay. And that's enough for our graph. All right. And then in our last one, y equals negative 2x plus 3. This part right here, this is going to do an upshift of 3. Okay, so 1, 2, 3. The negative, this is going to be flip the graph, make it be a frowny face. And then the absolute value of negative 2 is 2. So that's our absolute value of A. This is going to be make our graph stretched twice as much each time. So normally it should be going over 1 and up 1, but since we're flipping it over, it's going to go over 1 and down, and it's going to go down twice as much, so it'll go down 2 spots. Okay. Normally it would go over 2 and up 4, but since we're flipping it over, it's going to go downwards, and it's going to go down twice as much. So instead of going down 4, it's going to go down 8. So over 1 and down 8. 1, 2, 3. Or over 2 and down 8. 2, and then 1, 2, 3, 4, 5, 6, 7, 8. And here's our spot. Okay. And that's all that are going to fit. So we won't cross over that next line before the end of the parabola here. And there's our graph. Okay. So in both of these, it said compare the graph with y equals x squared. So this is what we're talking about. This graph is going to have a open upward, same as yx squared, and it's going to only open half as much as we go, and it's going to be shifted down 4. For number 16, we're going to shift it up 3 from the original. It's going to flip upside down because of the negative, and it's going to go down twice as fast because of the absolute value of A. Okay, so that's what it means by compare with the graph of y equals x squared. All right, this completes our notes for today. But if we flip back real fast to number 9 and 10, it had those same directions. Compare with the graph y equals x squared. So let's talk about them one more time. Why did it flip over? So because a was less than 0, it did this to the parent graph, turned it upside down. And because the absolute value of a was 1/2, this gave it a vertical compression. Right? And then in number 10, because a was greater than 0, it still opened upward. And because the absolute value of a was equal to 2, this gave it a vertical stretch compared to the original. Okay? So all we need to do is change the original graph, the parent graph, to get our new one, okay, based upon what our values of a and c are. All right, I will see you next time in class. We will practice this and make sure that we have a good understanding of it before we start trying to figure out the b.